Hello, welcome to MathByTV. If you're preparing for an Algebra 1 SOL or major Algebra 1 exam, this review is for you. Today we're working through must-know Algebra 1 problems step by step, including equations, functions, systems, quadratics, probability, and more. Pause the video anytime and try the problems on your own first. All right, let's get started. All right, so here is problem number 1. We have to simplify this expression. As you notice, we have 3 that has to be distributed to both terms in the parentheses, the 4x as well as the -7, and then the same for -2 is being distributed to x as well as to +5. So let's go ahead and work this out. 3 times 4x is 12x. 3 times -7 is -21. -2 times x is -2x. And finally, -2 times +5 is -10. So of course, we'll go ahead and combine like terms. 12x and -2x is equal to 10x. And then we have -21 and -10, which equals -31. Our final answer is 10x minus 31. Okay, and I will say students often forget to distribute the -2 to both terms. So that's very important that you do that. Let's go ahead and move on to problem 2. Okay, here is problem number 2. We have to evaluate when m equals -3 and n equals +4. All right, so let's go ahead and substitute carefully. We have 2 times m, which is given to us as -3. And don't forget that is being squared. -5 times n is given to us as +4 plus 6. Now, -3 squared becomes positive, so just recall that because a negative times a negative is a positive. So we have 2 times 9, and then we have -5 times 4. So that's -5 times 4 is -20 plus 6. 2 times 9 is 18 minus 20 plus 6, and your answer is 4. Final answer. All right, let's move on to problem number 3. Here's problem number 3. So first of all, we have to solve this equation. The first thing I notice is that we have variables on both sides. So move the variables to one side. So on the right, I have 4x. I'm going to move that 4x to the left side by subtracting 4x from both the right and the left. And so when we do that, we end up with 3x minus 12 on the left. Of course, the 4x minus 4x cancel out. And that is set equal to +15. And then here we're going to go ahead and add 12 to both sides because remember the ultimate goal is to solve for that variable. So we'll add 12 to the left and to the right. We see here that we are left with 3x equals 27. Solving for x, we'll go ahead and divide by 3 on both sides. And x equals 9. And that's the final answer. Let's move on to problem number 4. Here in problem number 4, we're going to solve this inequality. 4x minus 9 is greater than 15. So let's go ahead and add 9 to both sides. Okay, so on the left, we are left with 4x. The 9's cancel out. 4x is greater than 15 plus 9 is 24. Now divide by 4. And x is greater than 6. All right, so now let's match our answer to the graph. Pause the video and decide which graph below correctly represents the solution. Because the inequality is greater than 6, the graph shades right. So immediately I see that I can eliminate answer choices C and D because they're both shaded to the left. And because the inequality does not include 6 itself, we use a dashed boundary line. So that tells me that I can also eliminate answer choice A because it's using a solid boundary line. So the final answer is answer choice B. X is greater than 6, which is representative of this graph. Now, be careful here because I will say many students accidentally shade the wrong direction or use a solid boundary line instead of a dashed line. So the final answer is X is indeed greater than 6. Answer choice B. For this problem, we have to determine whether the relation is a function. Remember, a function cannot assign two outputs to the same input. Let's take a look at the input values, which are the x values. We have -1, 0, 3, and -1. So I see that -1 maps to both 2 and 8, which means that this is not a function. So I'll just say not a function. All right, represented by that red X there. Let's go ahead and move on to the next problem. So here for problem number 6, it says the table below shows the number of hours studied and a student's test score. So first of all, I want to ask you a question. What pattern do you notice? Well, hopefully you notice that the test scores increase by 6 points each time. So it increases from 72 to 78, and then from 78 to 84, and from 84 to 90. Now the next question I want to ask is, does this represent a function? Well, the answer is yes. And the reason why is because if you notice, each input has exactly one output. There are no input values repeating. All right. So with that, let's go ahead and move on to the next problem, problem number 7. Here's the next problem. We have to find the slope between -4, -1, and 211. Recall the slope formula, which is m, which is your slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I would suggest labeling your points here. Of course, we have x sub 1 here, x sub 2 here, and finally we have y sub 1, y sub 2. Go ahead and plug in your values. So we have m equals, and y sub 2 is given to us as 11. So that is 11 minus y sub 1 is given to us as -1. And then in the denominator, we have x sub 2. X sub 2 is given to us as 2 minus x sub 1 is given to us as -4. All right, so let's go ahead and calculate the slope. First of all, I want you to see that in the numerator, we have two negatives next to each other. Well, Do you see that? It creates a smiley face, so it's positive. So that becomes 11 plus 1. Take a look in the denominator as well. We have two negatives right beside each other, a double negative, and that creates a positive. So we have 11 plus 1 over 2 plus 4. So let's do that calculation here. So we have m, which is the slope, equals 12 over 6. And 12 divided by 6 is 2. Therefore, the slope is 2. Final answer. All right, let's write the equation of the line with slope -3 that passes through the point 2, 1. So we know we have to use the slope-intercept form, and that is y equals mx plus b. So let's go ahead and highlight a few things here. We're given that the slope is -3. Okay, so that's our m. And then the point, or the slope passes through the point 2, 1. So we know that x is 2. And then y is 1. So y is 1. So let's go ahead and fill in those values. So we have 1, and set that equal to m, which is -3, which is the slope, times x, which is 2, and that is 2, plus b. All right, so as you can see here, you know that we're solving for b, which is the y-intercept, right? Because you have everything else you need for the equation. But let's go ahead and finish solving this. And so we have 1 equals -3 times 2 is -6 plus b. Solving for b, all we have to do is add 6 to both sides. And we see here that 7 equals b, or b equals 7. All right, so now we can write that equation because we have everything that we need now. So that is y equals, and m is -3, recall. So that is -3x plus b, and b is 7. Y equals -3x plus 7 is your equation. Final answer. For problem number 9 here, we have to solve using substitution. So let's set the equations equal to each other. We have 2x plus 1 equals x plus 7. So the next thing to do here is to subtract x from both sides. So from the right and from the left. And you see here that we are left with x plus 1 equals 7. So the next thing to do is to subtract 1. Subtracting 1 from the left and from the right. And you see here that we are left with x equals 6. All right, so now we substitute back. So I'm going to use this equation. So where you see this x, you'll just place a 6 there. So that is y equals 6 plus 7. And y is 13. All right, so now we have x is 6 and y is 13. And that's the point. Final answer. Okay, so let's go ahead and move on to the next problem. Here we're solving using elimination. So first of all, what I'm going to do is add the equations. and that is 6x equals 18. And we're going to solve for x. We can divide by 6 on both sides, so x equals 3. Now let's just go ahead and substitute back. So I'm going to use this first equation here, so that way I'm not dealing with any negatives if I don't have to. We have 3 times 3 plus y equals 14, because now we're solving for y since we've already solved for x. 3 times 3 is 9 plus y equals 14. Solving for y, we can go ahead and subtract 9 from both sides here. And we are left with y equals 5. So the final answer is 3, 5. So let's go ahead and move on to the next problem. Here we're working with exponents and polynomials, and we have to simplify. First thing is first, multiply coefficients first. So as you can see, we have -2 being multiplied to +5. So I'll go ahead and write that down. -2 times 5, and that equals -10. Next, add exponents with the same base. Let's take a look here. We have x to the 4th power, and we have x cubed. Since they have the same base, we're going to add the exponents. So that is x to the 4th plus 3, which equals x to the 7th power. And lastly, we have y squared being multiplied to y. And remember, it's understood that this is y to the 1st power, so we are adding the exponents of 2 plus 1. So that is y to the 2nd power plus y to the 1st power, and that equals y cubed. So putting all of this together, we have -10 times x to the 7th times y cubed. So that looks like this. -10 x to the 7th times y cubed. Final answer. So for problem number 12 here, we need to simplify. I do want to state first of all is that you have to distribute this subtraction sign carefully. So basically you're distributing it to each term within the parentheses. And whatever signs are on these terms in the parentheses here will become the opposite. So I'll go ahead and tell you what I mean. Let's first go ahead and write this out. We have 6x squared minus 4x plus 9. And so this minus sign is going to change the signs of each of these terms to their opposites, okay? So positive 3x squared is going to become negative 3x squared. And positive 8x is going to become negative 8x. And finally, -5 is going to become positive 5. Now all you have to do is combine like terms. We have 6x squared minus 3x squared, and that is 3x squared. And then we have -4x and -8x, which is -12x. Finally, we have positive 9 and positive 5, which is equal to positive 14. So the final answer is 3x squared minus 12x plus 14. Okay, so here we are on factoring and quadratics. And we're told to factor completely x squared minus 11x plus 24. So we need two numbers that multiply to positive 24 and add to negative 11. Right off the bat, the two numbers I'm thinking of are negative 3 and negative 8. The reason why is because negative 3 times negative 8 is positive 24, and negative 3 plus negative 8 is negative 11. So the factored form is, and I'll write that here, x minus 3 times x minus 8. And that's the final answer. Here we need to solve x squared minus 7x plus 12 equals 0. So what we're going to do is factor the trinomial, and we need to do that by finding two numbers that multiply to give us positive 12 and add to give us negative 7. And so those two numbers are negative 3 and negative 4. So we have x minus 3 times x minus 4 set equal to 0. So now let's set each factor equal to 0 and solve for x. X minus 3 equals 0. Solving for x, x equals 3. And then we have x minus 4 equals 0. Solving for x here, x equals 4. So that means x equals 3 or x equals 4. And that is the final answer. A scatter plot shows that as the number of absences increases, final exam scores decrease. Which statement is true? Positive correlation, negative correlation, no correlation, or nonlinear correlation? So think about it. So we have absences increases, final exam scores decrease. Well, because one variable increases while the other decreases, this represents a negative correlation, which is answer choice B, final answer. Here is problem number 16, and it reads, a line of best fit predicts a student's score should be 88, but the actual score was 93. Find the residual. So I'll just go ahead and highlight some keywords here. So we have predicts, we also have actual score, and residual. So let's go ahead and use the residual formula, and I'll just go ahead and abbreviate that. So we know that R is for the residual equals A is for actual minus P is for the predicted. All right, so a line of best fit predicts a student's score should be 88. So where we see this P for prediction, we'll place 88 there. And then for A, which is for actual, that score was 93. So we'll place 93 here. So let's go ahead and find the residual. 93 minus 88 equals 5, meaning that the residual is 5. Okay, and that is the final answer. Okay, so here we are working with probability and exponential functions. Problem 17 reads, a bag contains 6 black tiles and 5 white tiles. 2 tiles are drawn without replacement. Find the probability of drawing 2 black tiles. So for the first probability, we have 6 out of 11. So remember, the top number is 6. The total number on the bottom is 11. All right. Now we have to find without replacement. So remember, without replacement means one black tile is gone, meaning that the total on the bottom is 10. And now the top number changes to 5. All right. And so now we can go ahead and multiply 6/11 times 5/10. And that is equal to 30 over 110. Simplifying, we get 3 out of 11. And that is the final answer. Okay, so here we have an exponential functions problem. And this says a phone originally costs $800 and loses 15% of its value each year. Which function models the value after X years? So go ahead and pause the video and see if you can identify the correct model. Well, the correct answer is answer choice C. Because the phone loses 15% each year, it keeps 85%, which becomes 0.85. And because the value changes by the same percent each year, this is exponential decay. Now, choice A represents exponential growth. Choice B would mean the phone keeps only 15% of its value each year. And choice D is linear, not exponential. Okay, so great job working through these Algebra 1 SOL review problems. Remember, don't just memorize steps, focus on understanding why the math works. Pause the video, replay difficult sections, and try the problems again on your own. And if this video helped you, be sure to like, subscribe, and share it with another student preparing for the Algebra 1 SOL. So keep practicing and stay tuned for more calm, clear math lessons right here on MathByTV.